Okay, so the type of equations you'll be asked to solve involving trigonometry, you'll be given a trigonometric equation like such I'm going to give. So the equation we're going to solve is 6 sine squared 3 theta 4 minus cos 3 theta. Then you're also given a range of theta values to solve for. So in our case, that's going to be theta is greater than 0, is less than 180 degrees. So we're just looking for solutions of theta in this range. First thing we want to do is we want this all in terms of either cos or sine with the same argument as well. So we don't want cos 3 theta and cos thetas and sine 3 thetas and sine thetas, or sine 3 thetas and cos 3 thetas. Easiest way to do this is we can convert the sine squared 3 theta in terms of cos squared 3 theta by writing sine squared 3 theta as 1 minus cos squared 3 theta. Then we get 6 minus 6 cos squared 3 theta is equal to 4 minus cos theta. Now we've got a quadratic in cos 3 theta. So we're going to write this in a slightly nicer form. So this is equal to 6 cos squared 3 theta minus cos 3 theta minus 2. That's equal to 0. Now we can factorize, giving 2 cos 3 theta plus 1 multiplied by 3 cos 3 theta minus 2 is equal to 0. And just like with normal quadratic equations, one of these brackets has to be 0. So either cos 3 theta is equal to minus 1/2, or cos 3 theta is equal to 2/3. And how do we solve this? Well, we just draw the graph up. We solve for one value of cos x equals minus 1/2. We solve for and then we draw a graph and we can solve for the other values. And I'm not going to go through this because you've seen it for GCSE and before specification. But what we're doing is we're solving for cos x, so we'll draw a graph of cos x. Okay, but the key point I want to illustrate is our x here is the same as 3 theta. Okay. So we want this minus 1, 1, and the cos graph looks like this, whatever. And that's in the range from 0 to 360. But because we're looking for theta between 0 and 180, 3 theta is between 0 and 540. Okay, because if you multiply an inequality by the constant, it remains still true. Okay, so to find all the values of theta that satisfy this equation, we have to find the values of 3 theta that satisfy this equation in the range from 0 to 540. And so that's what we look for. So for this equation, it turns out 3 theta is equal to 120 to 240 or 480, so either of those three. And solving this equation gives 3 theta equal 48.19, and this isn't obviously all decimal places, but the question will often tell you how many significant figures or decimal places to write your answers to. So we'll just go for 2 decimal places. And then all we do is divide every single one of these solutions by 3. So theta equal 16.06. That's dividing this one. 40, 80. That's dividing these two. I'm just writing them in ascending order. And dividing this one, we get 103.94. Then we get 136.06, and then 160. Of course, the reason we specify a range is because there are infinitely many solutions to this equation. What I would say is, for these types of questions, sometimes the range is so restrictive you might only get one solution, or maybe one of these quadratic brackets won't have any solutions. You might get cos 3t is equal to 4, and in that case it doesn't make sense because cos is between 1 and -1, so you would lose some solutions there. I would say, as a general rule, you usually, for the type of questions that SU A level, usually get between 4 and 8 solutions. But yeah, if you get 2 and you're sure you've done the method right, that's fine, or whatever. So the general points, you'll get different types, so it won't all be the same like this. Use your trig identities to write the equation in terms of one trigonometric function and one argument. Okay, so that's the first step. And that takes a little bit of practice, but we wouldn't have time to go through all the different combinations in these videos. You should just practice, and the more you see these sort of things, the more intuition you have. Then, if you've got an argument that's a multiple of theta, be sure to consider the range of values you're looking for solutions in. Yeah, don't just type in inverse of cos on your graph and take the first solution that comes up. Make sure you get all the solutions in the range by drawing the graph. And then the last thing really is make sure you write your answers to the correct amount of decimal places or significant figures. You don't want to lose cheap marks through this, okay, in your exam. That's it for this video, and I believe that's it for the trigonometry section. There are a couple more sections on identities, but other than that, loads of trigonometric identity questions on the channel. I will link all those short videos, they're only about a minute long, so there's just examples that you can try. You can click, you can pause it, see if you get it right. Okay, and then the other thing is also using trigonometry in real world problems, but we're going to come on to that when we do the mechanics section. Okay, so we've already looked a little bit at projectiles, but we're going to look fully at mechanics soon, so we'll go through that then. If you do have any questions, let me know in the comment section below. But for now, that's it. If you did enjoy the video, please be sure to like and subscribe. I really appreciate it.